So as you guys can see now in this video, we are almost to the boiling point. Right now we are at 85 degrees Celsius. So we are starting to see bubbles form around the base of the beaker because the molecules are now being heated up to a point in which they will be pulled apart and turned into from a liquid to a gas known as evaporation. So we are approaching the boiling point. We are now at 90 degrees Celsius. So we are beginning to see more boiling occurring. But we are increasing the thermal energy. We are transferring thermal energy from the hot plate into the water. So we are adding thermal energy into the water, which increases the movement of those molecules. So that increased movement of the molecules is causing them to boil. And once they're sped up enough, the water molecules are then going to be transformed into a gas state, which is what we're starting to see now. So we are approaching 100 degrees Celsius, which is the boiling point of water. And as you guys can see now, it might be hard to see in the video, but there is steam or water vapor coming out of the beaker, and we have reached a full boil. So what you will notice is that around the boiling point, if we leave this here for another couple minutes, the temperature is going to stay the same. And that is because we have reached the second point in the second flat line of our graph. Evaporation, the second phase change. So during this phase change, the temperature is not going to change because remember that energy is being used to rearrange the molecules from a liquid to a gas. So it's spreading out those molecules. So you can feel the steam coming out of the beaker being transformed from a liquid to a gas known as evaporation or vaporization. So we are increasing the thermal energy of these molecules, transferring them from a liquid to a gas. So our temperature is right at 102 degrees Celsius. And we'll let it run for a little bit longer to show you guys that even after 30 more seconds, it's still going to be at 102 degrees Celsius because we're still undergoing that phase change. Eventually afterwards, we might see an increase after that if we had more power or more heat. But due to the hot plate only getting so hot, we will only see the temperature increase to what it is at now, at 102 degrees Celsius. Also remember, things to consider is the theory that we talked about, the kinetic molecular theory. Remember that kinetic, like kinetic energy, means moving. So kinetic means moving, and then molecules, moving molecules. So this theory states that molecules make up matter. So molecules make up matter, and the kinetic molecular theory states that these molecules that make up matter are always moving. So that, very simply put, all of the molecules in matter are always moving, and that's what the kinetic molecular theory is. So our temperature is still at 102 degrees Celsius, so we're still at that evaporation phase change point. So our first phase change that we saw was moving from ice to liquid, so our solid to a liquid, which is melting. And then the second phase change that we saw was going from a liquid to a gas, also known as evaporation or vaporization. So once you guys have watched this video, I want you guys to fill out your data if you have not done so already. And I want you to use your data to mimic the graph that I've also posted on Canvas. You can use the same graph, but I want you to do it on your own and do it on your own paper. So make sure that you have all of the things at the top of the paper as well, all the things that are required of your graph to get full credit. And make sure to answer all of the questions on page 2, where it says answer the following questions. Make sure you answer all of those questions. But thank you for tuning in, and I'm sorry you missed the lab, but I'm glad that technology allows us to get you caught up.